All right, now we're going to do the second free response from review day 2. It gives us a table of values of f and g and their derivatives. First question we're asked is if k is f of g of x, can we make an equation of a tangent line to k at x equal 3? So anytime we see a tangent line, we need to be thinking point and slope. So as far as the point goes, we know x equals 3. We need to find h of, or k of 3. So when I put that in, that's going to be f of g of 3. So I need to find out what g of 3 is. So if I go to g3, that's equal to 6. So this is going to be f of 6. Now I go back up here, f of 6 is equal to 4. So I end up with 4 as my y coordinate. All right. Now I need to find the slope at that spot. So in order to do that, I have to take the derivative. So this is going to be a chain rule. The derivative of k is the derivative of the outside, leave the inside alone, times the derivative of the inside. So k prime of 3 will be f prime of g of 3 times g prime 3. All right. So g of 3 we just found earlier was equal to 6. So this is going to be f prime 6 times g prime 3. F prime of 6 is equal to 5. And g prime of 3 is equal to 2. So we end up with 5 times 2, which is 10. That's our slope. So y minus 4 equals 10 times x minus 3. This is our derivative. Now, they ended up giving 2 points for this slope here, and then 1 point for the equation. So I'm guessing you got maybe a point for showing the derivative as a chain rule, 1 point for calculating it correctly, 1 point together for this y value plus the equation. That would be how I would think they broke that up when they did that year. All right, so that was number 1. Not too bad, just got to be a little careful with the chain rule. Part B says let h be, we got a quotient here. We want h prime 1. So this one you should be feeling pretty confident in. We're just doing the quotient rule. So h prime of x is bottom times derivative of the top minus top times derivative of the bottom over bottom squared. And notice that they did f on the bottom and g on top in case you memorize something about f and g. Usually you'd have f on top and g on the bottom. They're purposely seeing if you understand the quotient rule or did you just memorize some trick. So you got to make sure you're clear. Bottom first times derivative of the top and then from there. Now, h prime of 1 then would be f of 1. So f of 1 is negative 6 times g prime 1, which is 8, minus g of 1, which was 2, times f prime 1, which is 3. I'm sorry, I'm pointing to something I'm not showing you here. Divided by f of 1, which is negative 6 squared. This is going to give us negative 48 minus 6 over 36. All right. And then if I do that, I get negative 54 over 36. That would be fine. Actually, this would be fine too, but it ends up simplifying all the way to negative 3/2. So having an expression, it says for h prime of 1 was worth 2 points. My guess is 1 point for the quotient rule, 1 point for plugging in the values correctly, and then 1 point for having the right answer. So 3 points for that one. All right. And then we come to C, and C says to evaluate from 1 to 3 f double prime 2x. So we know the integral of f double prime would get us to f prime. All right. The trouble is if I take the derivative of this, it's going to go f double prime 2x times 2. There'll be a 2 that pops out because of chain rule. I don't want that 2 to pop out. I want it to just be that. So when you do the integral of this, you have to be real careful. There's a 1/2 that actually exists here. U sub is actually a little tougher, I think, but you could try it. I think it's easier to go this route. All right, so they actually gave you 2 points for that antiderivative, meaning that they probably gave a point for recognizing that it was f prime. They probably gave you a point for recognizing the 1/2. The last point's going to be whether you can do the fundamental theorem. So that part's not too bad. We put 3 in. We're going to get 6 here. Minus, and put 1 in. We're going to get 2 here. So f prime 6 is equal to 5, and f prime of 2 is equal to negative 2. So we get 1/2 times 5 minus 1/2 times negative 2. And that's going to end up being 5/2 plus 1, which is 2/2. So we end up with 7/2 as our answer. That would be worth the last point. All right, so again, not too bad. A lot of variety in this problem, which I really think is what they're going to do this year. They're going to try to create problems that cover lots and lots of different topics and whatnot. So problems like this are really good to make sure you feel confident in.